distributive property for exponents. This 5 is going to end up being multiplied into the 2 and into the 3 separately, and then you can simplify from there. Actually, there's a number of ways you could do this problem. I'm going to show you a couple different. Let's do it the way I just told you. Let's say I can do that. The first one is going to be x, and then 2 times 5 is 10, times x, and then 3 times 5 is 15. Here we've sort of distributed the 5 into the exponents. 5 times 2 is 10, 5 times 3 is 15. And then in the final solution here, you just need to add the exponents because I've got x is the same thing and they're multiplied together. So 10 plus 15 is x to the 25. Okay, that's how to do it that way. Now let's say you tackle it differently. Let's say that I want to simplify the inside first. So going that way, I can simplify this by saying this is x to the 5 because the same base, and then 2 plus 3 is 5, and this is raised to the 5th power. And you see in this case 5 times 5 is 25. Same answer either way. So it's really not any different. Okay. Let's say I've got something like 3z times z squared times z to the 3rd all raised to the 5th power. Well, this one I'm definitely going to simplify the inside first. So what I'm going to do is I'm going to go ahead and simplify these z's by adding the exponents together. So what I'm going to have is, in the inside, 3, and then I've got a z, and a z, and so I can simply add these exponents. So 2 plus 1 is 3, 3 plus 3 is 6, so I've got 3z to the 6th power on the inside, and then I've got a 5 on the outside. And so I was able to simplify this by simply adding 1 plus 2 plus 3 gives me 3z to the 6, and then I've still got my 5 sitting out there. Now, in order to simplify this, okay, what I'm going to do is I'm going to multiply, it's sort of the distributive property. This 5 is going to be distributed into the 3, and it's going to be distributed into this z to the 6th here. So I'm going to end up with 3 to the 5 times, and then what I have here is z to the 6th to the 5. And so this is going to equal 3 to the 5 times z to the 30, because 6 times 5 is 30. And you can just do 3 to the 5 in your calculator. So if you're going to really do this, you go 3 to the 5th power in the calculator, and it'll be some number in front of z to the 30th. Now this looks complicated, but it's really not. Remember, all I did was I simplified these z's, and I put it in there, and that was all raised to the 5th power. And remember, anytime you have extra things multiplied by each other inside here, the 5 is going to kind of distribute in, just like it kind of did up here. 5 times 2, 5 times 3. So in this case, I've got 3 raised to the 5th power, because that goes in there, and then I've got z to the 6th raised to the 5th power, because it's distributed in there. In this case, this simplifies to 5 times 6 is 30, and then I just leave my 3 to the 5 out, because I don't have a calculator handy to simplify that. The basic rule of thumb is if you've got multiple things multiplied together inside of some parentheses, and you've got an exponent hanging out, you're raising the entire thing to some power on the outside, that exponent is going to be sort of distributed in, and everything on the inside is going to be raised to that power. Okay. And a good example of that is the following. This is a good example of that. Let's say we have r to the 3rd times r squared raised to the 4th power times r to the 3rd, r to the 5th raised to the 2nd power. Well, I've got things, there's two ways I could do this problem. I could simplify the r's on the inside and simplify the r's on the inside, and then I'd have an easy problem, but I'm going to do it a little bit different way. I'm going to distribute this exponent in. So I've got r to the 3rd raised to the 4th power times r squared raised to the 4th power, and then over here I've got r to the 3rd raised to the 2nd power, and then over here I've got r to the 5th raised to the 2nd power. All I've done is take these exponents and kind of distribute them in accordingly. Okay, r to the 3rd raised to the 4th power is r to the 12th, because 3 times 4 is 12. The next one's going to be 2 times 4 is 8, so it's r to the 8th. The next one's going to be 2 times 3 is is 6, r to the 6, and the final one's going to be 5 times 2, which makes r to the 10th. Okay? And then all you really have to do at that point is add them all up. Okay? So what I'm going to have here, these two, I've got r to the 12th times r to the 8th. These two right here, they're going to go r to the 20th. Okay? I've still got my r to the 6th, and I've still got my r to the 10th. Okay? These two are going to give me r to the 30th, r to the 6th. All I'm doing is adding 20 plus 10. And so in the final solution, it's going to be r to the 36th power. Okay? It's really not that bad. Okay? All I did was I distribute this exponent in both times. I have it all multiplied, because remember, it's all multiplied together. And then I simplified each exponent separately, and then I can simply add the exponents because all the bases are the same. So I just added them all. I did it in several steps because it's easier for me to add in my head if I add certain things together. But if you had a calculator, you could just go 12 plus 8 plus 6 plus 10. You get 36. Okay. I think that's going to about do it for how to handle exponents raised to exponents. So the basic lesson in life here for this class of problem is for, backing up a second, for exponents that are kind of added together with other exponents, you can, multiplied together with other exponents, you can add the exponents together. For exponents that are raised to other exponents, you simply multiply them together. Now we're going to do a little bit of the same stuff, but I'm going to introduce division here as well. Okay, so let's say we're going to work a little bit with mixed variables. What if I have x, y to the third? Okay, now these variables are not the same. They're multiplied together, but they're both raised to the third power. And we kind of alluded to this in the previous lesson, but the way you handle this is everything in here has to be kind of distributed and raised to the third power, like that. So what I'm going to have is x to the third multiplied by y to the third. The 3 just goes in. Okay, what if I have r to the third times s squared all raised to the second power? Again, I've got r to the third raised to the second power, because I distribute this 2 in. This quantity is raised to the second power, multiplied by s squared quantity raised to the second power, because this thing is going to be raised to the second power. And then when I simplify this, r to the third raised to the second power is r to the 6th, because 2 times 3 is 6, multiplied, and then s to the second power raised to the second power is going to be s to the 4th. And just simply writing this together is r to the 6th, s to the 4th. Okay? Now what if I have something like negative 2 r squared s to the third t all raised to the third power? Again, everything in here is multiplied together. I can't simplify the inside at all, okay? Because they're all different variables. I've got a 2, an r, an s, and a t. There's no way I can simplify this, but when this exponent gets applied to the whole thing, it's applied to each thing individually, kind of like the distributive property. So what I've got is negative 2 raised to the third times r squared raised to the third times s cubed raised to the third times t raised to the third. And all I did here was take each individual term and raise it to the third power, and they're all multiplied together. You can simplify this. Negative 2 raised to the third power is negative 8, and you can convince yourself of that by taking negative 2 times negative 2 times negative 2, and you do that and you'll get negative 8. Okay, multiplied by, and this simplifies and it goes to r to the 6th, because 2 times 3 is 6. The next one simplifies as s to the 9th, because 3 times 3 is 9, and the next one simply stays as t to the third power, because that's pretty much all there is left, is the t to the third. So it's not too bad. Now we're going to do some things with division. We've learned how to handle exponents when they're multiplied together. We've learned how to handle exponents when they're raised by other exponents. Now let's figure out what to do when exponents are divided by other exponents. And this is going to be kind of the same thing, but before we get there, I'm going to show you how to handle something like this. What if you have a divided by b, and this is raised to the third power? Now this is interesting, and it's a little bit different than when they're multiplied together. You still need to distribute the 3n, the exponent 3n, but the way it ends up working is you put an a cubed on the top and a b cubed on the bottom. So anytime you have a fraction in here and you raise it to a power, the top is applied to that power and the bottom is applied to that power individually, like this. And then the result is divided. You know, you do the a cubed and the b cubed and you take the division of those two, and that gives you the answer. We'll do a couple more examples. Let's say you have x squared on top and y to the third on the bottom. Okay, and then you raise the entire thing to the fifth power. Well, the top needs to be raised to the fifth power and the bottom needs to be raised to the fifth power. So in this case I have x squared on the top raised to the fifth power, and on the bottom I have y to the third also raised to the fifth power, because remember, top gets raised by the power and the bottom gets raised by the power. On the top I'm going to be left with x to the 10th, because 2 times 5 is 10, and on the bottom I'm going to be left with y to the 15th, because 3 times 5 is 15. So all you really do there is you apply the exponent to the top and the exponent to the bottom when you have it like that. It's not really too different. This is a little bit different. So let's say you have something like negative 2a on the top over b raised to the fifth power. Okay. Well, how am I going to handle that? I got to raise the top by the fifth power and the bottom by the fifth power, but the top is a little complicated, so I'm going to take it step by step. On the top, I'm going to have negative 2a raised to the fifth power. On the bottom, I'm going to have b raised to the fifth power, because I've got to apply the power to both of them. All I need to do is figure out how to simplify the top, and we already learned how to simplify the top in the last part of the lesson, because I've got this exponent of 5 that's going to distribute into the negative 2, and it's going to also distribute into the a. So I'm going to have as negative 2 raised to the fifth power times a raised to the fifth power, because it goes into both, divided by b to the fifth power. And that's really the answer. And if you wanted to simplify it even more, you could take this negative 2 and put that in your calculator and raise it to the fifth power. You know, and then you have a number here, a to the fifth over b to the fifth. So that's pretty much how you handle the fractions. It's not that different than when they're just all multiplied in there together. It's just basically when you have a fraction, you set the top, you know, raise the top of it to that exponent, and you put the bottom of it to that same exponent. And that's how you simplify those. Now, let's use all of the tools that we have learned, and let's try to go ahead and proceed further. What if you have something that looks like x to the fifth over x to the third? How do we simplify that? Now this looks a little bit different. We don't have some fraction that we're raising to a power. We have x to the fifth and we are dividing it by x to the third. And this is going to be one of those few times where I'm going to actually try to prove something to you with kind of making it long, and then I'm going to just show you the shortcut. Okay, first of all, the answer is, the quote shortcut to remember is, anytime you have the same base on the top and the same base on the bottom in a fraction, and you're raising the top to an exponent and the bottom to an exponent, you basically, all you have to do is take the difference in the top and the bottom. You take 5 minus 3, and that's going to be the answer. So it's going to be x to the 2. Okay, that's going to be the answer. Yeah, so it's not really that difficult. You can see that there's some symmetry here. Sometimes you add the exponents, sometimes you subtract them, sometimes you multiply the exponents. So it's really not too many things to remember. It's just that you can imagine it as this. Let me prove to you why this is the case.